Hello and welcome to another lecture in the Abralim ao Vivo series. Abralim ao Vivo is an initiative of the Brazilian Linguistics Association. I am Miguel Oliveira, president of Abralim. Today, I'd like to introduce Gary Lupyan, a professor of psychology at the University of Wisconsin-Madison, where he studies the effects of language cognition and perception and the evolution of language. The title of his lecture today is How Language Structure Our Mind. Before we start, I'd like to thank Gary Lupyan for accepting Abralim's invitation and to say that questions and comments are very welcome in the chat. Please join me in welcome Gary Lupyan.
Thanks for having me. It's an honor to join the club of Abralim presenters. I'm going to talk about how language structures our mind. We look at a scene like this and we make sense of it. Winter, people, dogs, trees, mountains, ice skating, hunting. Might notice the cooking going on in the background. How do we know the color of this dog is the same as the color of these bricks? Well, you just look at it. How do we know there are 6 ice skaters on this pond closest to us? You just count them. Sure, we need language to talk about these meanings, but the meanings themselves, the concepts, the ideas, the notions, to use John Locke's term, those just seem to be out there in the world for us to grab onto. An alternative view of how we come to make meaning of the world around us comes from people like Sapir and Worf, who were original in their own respects, but followed a long tradition of many centuries of thinking about language as an aid to constructing our reality. So almost 100 years ago, Sapir argued that it's an illusion to imagine that one adjusts to reality without the use of language. And he also talked about culture more generally, and that language is merely an incidental means of solving specific problems or communicating or reflecting. The real world for Sapir was to a large extent that unconsciously built up on the language habits of the group. Worf famously argued that we dissect nature along lines laid out by our native language. The categories and types we isolate from the world, we do not find there because they stare every observer in the face. Rather, the world is presented in a flux of impressions, has to be organized by our minds. And I should add that this idea of the world being constructed and organized by our minds is, for many of us in cognitive science and cognitive neuroscience, is something that we all buy into. We don't have some privileged immediate access to the world, we construct it. But controversially, Worf argued that language plays a role in this construction. So on this view that we understand this scene in one way or another is not an objective fact about the scene or the world at large. Rather, we understand it in the context of language. And one consequence of bringing language into this is that because language is different to the extent that they do, different patterns of naming, different grammatical systems might lead us to construct reality in somewhat different ways. So this view has been controversial. Just to give you a sense of this controversy, so here's Pinker in The Language Instinct, acknowledging, of course, the importance of language for communication, but arguing that this crazy notion that language shapes our thinking is something that we thought when we were in the dark about how thinking really works. This passage from Henry Gleitman comes from an introductory psychology textbook. No doubt influenced by Lila Gleitman. Here's from a paper by Gleitman and Fisher, expressing the idea that we map our thoughts into words, but the thing being mapped into words arises independently of language. Does language have a dramatic effect on thought in some other way than through communication? We learn, of course, by talking to one another, but other than that, probably not. And in this quote that has puzzled many, the philosophers of language, De Witt and Sterelny, the only respect in which language clearly and obviously does influence thought turns out to be rather banal. Language provides us with most of our concepts. Now, how important could that be? So there's another perspective, just to give you a sense of some of the range of thoughts from Melissa Bowerman, Steve Levinson, expressing the idea that it's not just that language reflects our thinking, it transforms it. Andy Clark arguing, along with Annette Karmeloff-Smith, Dan Dennett also made some very similar points. The idea of language allowing certain representations for making them available for inspection. And from Gentner and Christie, arguing that language plays a critical role in facilitating analogical reasoning. And so there's this gap in perspectives. And it would be one thing if this gap narrowed over time as we came to possess more data. And this is not happening. And I want to argue that it's not happening because a lot of the conversation about this topic leads us into quicksand. And so in the first part of the talk, I want to try to sort out some of the talking past one another that we've been doing that leads people who, in many cases, are aware of a lot of the same data, but interpret it very differently. So let's try to see the quicksand and avoid it. It's much easier than getting out of it once we're in it. And then in the second part of the talk, I'll present a bunch of data speaking to the more specific question of whether words help structure our minds. And the specific form of this question has to do with the role that words play in a few different kinds of categorization and reasoning. Okay, so let's try to see and avoid this quicksand. So the first thing we're going to do is define some terms. And I'm not a philosopher, but I've come to really respect and admire the philosophical tradition of being accurate with the words that we use, because it's all too easy for people to use the same word to have it mean different things, and all sorts of mess ensues. So conversation about the effects of language and thought uses words like language and concepts and thought and linguistic systems and semantics, and talking about language affecting thought, representations, competence, and performance. And so I want to spend a few minutes on this terminology. And so language. And so what do we talk about when we talk about language? I'm glad to see that one of the discussants will be Idan Blank. We had a back and forth on Twitter in response to his recent talk, where, along with F. Fedorenko and colleagues, Idan takes a particular view of language that, from which I think several conclusions follow, but those conclusions follow from taking a specific perspective. So let's see where this takes us. So the view here is that we can identify certain neural substrates, what Idan terms in the slide as language proper, part of the core language network, that are reliably activated in various linguistic tasks. And we can see if those same substrates are activated in other tasks. So for example, arithmetic. And so we see here the core language network being active for sentence reading and intact speech, but not for various math tasks. And one conclusion we can draw is that these math tasks are not linguistic. They do not draw on language resources. And so using this kind of logic, we can conclude that language is actually very circumscribed as a process where all of these other processes, spatial reasoning, action observation, arithmetic, have little to do with language. I love this work. I think it's excellent work, but if we take a somewhat different perspective on what language is, we might come to different conclusions. So here is another way of thinking about language. What is language? It's an open-ended communication system. As a consequence of being an open-ended system, a bunch of things follow. It has to be learned, or how else could it be open-ended? It has to be categorical, compositional. I don't have time, unfortunately, to back up those assertions. So we've got this system that is socially learned. And from birth, even before birth in some respects, we have both linguistic experiences and we have non-linguistic experiences. So this distinction is quite sensible. So we talk to people and we read and we think about what we're going to say. We ask questions using language. And of course, we have non-linguistic experiences. And the two are related. Of course they are. And so, oops, sorry. And so we can ask, how do linguistic experiences affect non-linguistic ones? Notice that this form of the question makes no reference to linguistic versus non-linguistic representations. Rather, the distinction is between linguistic experiences and non-linguistic experiences and how they might interact and inform one another. Thought here, I'm not sure, I don't think there is any disagreement. So it makes sense to distinguish thinking for language, so it's a form of cognition, from the various processes involved in tasks that are plausibly non-linguistic, but might nevertheless, it's an empirical question, be affected by experience with and use of language. To these, I would add important tasks like categorization, inference, relational reasoning. What are we talking about when we say affect? And here people mean very different things. So in a paper from 2010, Wolf and Holmes have this schematic of different forms of the assertion of language affects thought. And the first distinction is between separating thought from language and creating an isomorphy between them. So thought is language, or that they're basically parallel. The thing is that while these are logical possibilities, Worfians don't think this. Worf himself, in his writings, not that it matters that much, never endorsed what has come to be called the strong Worfian hypothesis. If you want to read more about it, I strongly recommend this paper by Steve Levinson. So this here is kind of a red herring. It's, again, logical possibility, not something anyone who's doing empirical work on this takes seriously. This, on the other hand, these are all distinct and quite interesting possibilities. It's useful to distinguish between these. The one quibble I have is that we don't need to talk about linguistic representations and non-linguistic representations. It's hard to observe representations. It's hard to classify them. There's nothing in the brain that says, hey, this is language. We could do this kind of inverse, this inference. This is active in the language task, so we're going to label it as a linguistic representation. But we don't need to engage, I would argue, in this kind of chain of inference. Instead, let's focus on experiences. These are easy to observe, easier to classify. So what do people think and do because they've learned language that they wouldn't think and do otherwise? Okay, and so another question arises, wouldn't think and do otherwise or couldn't. Okay, and this is a form of a competence and performance distinction. Now, in theory, one could code the game Call of Duty using punch cards. This is in principle possible. This is what the 1950 Sage air defense system, the code on punch cards looked like. That's about 65,000 punch cards. These have about 5 megs of data. One could do this, but one probably wouldn't. And so for me, and to the extent that it matters for Worf, the concern has always been with habitual thought, not what is possible in principle, but what is possible in practice. What do people tend to do? Another way of stating this is that linguistic experience is just a form of experience. And so the question is, well, what kind of experience precisely is it? But there's nothing magical about it. The one interesting property it has is that it affects everyone in the community. And so, for example, Steve Levinson argues that to drive a car, you need to acquire certain motoric cognitive skills. Okay, if you don't drive a car, you might acquire those skills in other ways, but you don't need to, right? But if you're going to be a driver, you're going to need to master certain skills. Now, when it comes to mastering certain linguistic devices, every speaker has to master them, right? So it says to speak Tsaltal, you need to do base 20 math in your head. That's just like we do base 10. It has a different number system, so you get good at other things. It has a geocentric reference frame, and so you get really good at keeping track of which way you're facing, because you need to just say where things are. Now, do you need language to become good at this? No, but when it's built into the language, everyone in the community becomes aligned and gets good at it. So language has this interesting property of enforcing expertise in certain domains. I mentioned this puzzling quote. This is puzzling because it's in the context of arguing that language doesn't really matter for thinking. And one reason why someone might agree with this quote, that we learn so much from language, is that, and yet think that it doesn't really matter, is that they think that these concepts of language we would come to have anyway. And there is reason, as I'll show in the data, to think otherwise. But even if there is formal equivalence between certain concepts like 10 tens and 100, there's something about the chunks, the cognitive chunks that are provided by the vocabulary of a language, that in learning, it unifies all these properties so that 100 becomes a better conceivably cognitive chunk than something that is equivalent in meaning, but like 10 tens, but not quite psychologically the same thing. So I look forward to hearing from people about whether that helped to clear anything up. But in the interest of time, let's go on to part 2, to the empirical part. Do words help structure our minds? So the question here is, do the words we learn as part of learning a language help to create some conceptual structures? Do they help us induce certain categories, learn certain categories? Do they help in making certain generalizations? One reason why the answer to this question might be no is that one might think that words that we learn in the language, we learn because we already have the underlying concepts. And so this is a view strongly espoused by Lila Gleitman, who argued that words are straightforward mappings of our concepts. But there's another way of, and so if that's the case, there's not really any room for thoughts to, for words to influence our concepts. There's another, however, way of thinking about the relationship, which is that words, in certain respects, are just like any other kind of cue. So you learn, what the color of an apple is from seeing it, and you can also learn something about the appearance of apples from language. Okay, and so if we think about our semantic or conceptual knowledge, I use this term broadly to mean basically world knowledge, including our knowledge of words, of word meanings. Part of our knowledge about the world comes from perceptual experiences, our actual direct interactions with the world. Part of it may be informed by various innate knowledge, core knowledge. Part of it comes from language. I don't just mean, as we'll see, I don't just mean that we learn what the capital of France is from language. Although of course we do, we learn pretty much all of history we know from language. We have no other way of learning it. But we learn that green is a thing, and 5, 6, and 7 is a reasonable sequence, right? That's the more general idea. We learn that colors are things worth naming, right? So this is this kind of stuff I'm getting at when I say learning from language. Okay, and so if you think about words as helping you construct meaning more generally, then some questions arise. One question is, well, what kind of cues are words? Is there something special about them? Is there something different about learning that lemons are yellow from seeing lemons and from someone telling you that lemons are yellow? Okay. And then what kind of effects do labels have? All right, so what kind of cues are words? So here's the idea in a nutshell. Most words denote categories. This is certainly true of open class words like nouns and verbs. The world, however, is largely not categorical. It's structured, it's chunky, but it's not really categorical, right? So in the case of colors grade continuously from green to blue, but language doesn't. Where there is structure, so saliently, for example, in the biological world, right? So there are dogs and there are other animals that are not dogs, okay? But where do you draw the boundary, right, between dogs and feral dogs and wolves? Where do you draw the boundary between shrubs and trees, right? A lot of these basic terms are at least partly socially constructed. They don't respect any sort of taxonomic biological objective truths. Now, because the world is largely not categorical, and when it comes to things like, in, on, various relational terms, right? These are categories that do not correspond to objective reality. They're just a good way of construing spatial relations. So as a result, there's always a discrepancy between the world and language, and there is lots of room for cross-linguistic differences. Okay, and so, for example, if we consider an English lexical category like open, we might appreciate that there are different kinds of scenarios, kinds of instances that we as English speakers label as open events. And to the question of why do we label them as open events, why do we construct this category, one might say, well, because they belong together, right? And they do, it's not arbitrary. There is a sense to why these things go together, and why these ones are not things that we label as open events. But there's more than one way to do it, right? So the same situations are construed differently by Korean. It uses a different set of categories. And a Korean native speaker learning English might be a bit puzzled as to why English puts all of these into the same category. Right. The same categories, as Worf argued, do not stare every observer in the face. So one example of this is the language of perception. The authors here, Majid and colleagues, looked at 20 languages and at whether there is, as the ancient Greeks had it, there's a natural hierarchy to the senses such that some are inherently more nameable. Colors and shapes are inherently more nameable than sounds, than touch, different textures, tastes, and smells, right? So these were argued to be inherently less nameable, less more ineffable, and these the most, just by how the world is. Okay, and what you find when you actually collect the data and do the comparison, this is just a name agreement task, is this original hierarchy is not really respected. There are differences, mean differences, so smells on average are less codable, but there are languages in which it's the most codable modality, and many taste is. Most relevantly for the data I will show you, shapes and colors are not readily codable in many languages. And if we zoom in on the kind of differences we find, we see, for example, for colors, it's not just that some languages have larger categories, like a category that includes blue and green, while languages, well, say English is more particular and divides it up, but rather there is the colors that are easy to name are different in different languages. Okay, so whereas in English, these colors don't really get reliably named, in Lao, other colors don't get reliably named. And if we look at correlations between languages as to which colors are easy to name across the different languages, they're mostly positive, but not strongly so. These are moderate to weak correlations. And for some languages, the correlations are basically near zero. And so colors that are nameable in one language are not necessarily nameable in another. The color naming patterns are not willy-nilly. They're strongly constrained, as a lot of excellent work by Terry Geer and Ted Gibson, among others, have shown. But neither are they so strongly constrained as to not have variability. If you take, the lesson here is if you take a continuous space like color and you impose a set of categories on it, there's more than one way to do it, and there's more than one solution to it. Okay, so what's so special about words as cues? And it's the last bit before a torrent of data. One might think that learning something from language is in principle similar, identical to learning it from other things. There are, of course, things that are easier to convey through language, things that are more difficult, but in principle, it shouldn't matter much. Ruth Millikan, in a BBS paper from 1998, talking about different ways of knowing things, wrote the following. Sure, there are many ways to recognize rain. There's a way rain feels when it falls on you, a way that it looks through the window. There's a way that it sounds falling on the rooftop, and a way that it sounds falling on the ground. And falling on English speakers, here's another way it can sound. Hey guys, it's raining. But there's a difference. And that difference is that whereas every perceptual experience of rain is specific, whether it's visual or auditory, the modality doesn't matter here. It is specific. It's a specific episode. Language allows us to abstract away from the specifics. We can, if we want to, elaborate and construct a very detailed approximation of what this particular rain was like, but we can also abstract, and we tend to do that, and just say it's raining or it rained. And this gives language some important powers that are not, I would argue, paralleled in perception, which is that language can abstract things and name the category that we are interested in. All right. So what's special about language is that it is this categorical system that can abstract away from the features of the category that are irrelevant, and emphasize the things that make it relevant. What kind of effects do they have? So the claim is based on the kind of property that language has, that words have, is that words will induce more categorical mental states. So knowledge cued by words is more categorical. If true, then it should help categorization. It's the ideal cue for categorization. It may interfere with certain other things like memory for details, and there's some evidence for that as well, but I'm focusing on categorization here. Interfering with language should interfere with categorization. The argument isn't that you cannot categorize something without language. The argument is that habitually, language has these effects, and as language users, we come to rely on them. Finally, more nameable categories should be easier to discover, to induce. So here's the first experiment. So the idea is straightforward. We're going to take familiar categories like dogs. These are things that people already know about. They know what dogs look like, what they sound like, and they know that dogs are called dogs. So they have some conceptual representation of dog. And let's compare how it's activated using the word dog compared to some other non-verbal cue. So if, for example, as Lee and Gleitman would have it, that linguistic categories and structures are just straightforward mappings from a pre-existing conceptual space, it doesn't really matter how you get at the concept. It's the same thing. The experiment is very simple. We present people with cues that are either auditory words or characteristic sounds made by these objects or animals, and we norm all of them to make sure that all the sounds are perfectly recognizable. Everyone knows this is a guitar sound. And then we show people after a delay a picture, and they press a yes button if the cue matches the picture, and a no button otherwise. So in this case, if they hear a guitar or a guitar sound and they see any kind of guitar, they would press yes. If they see something else like a dog, they would press no. Now, any picture of a guitar has to be a picture of some specific guitar. For example, it has to be either an acoustic guitar or an electric guitar. I can't just have a guitar. The same goes for its sound. But the label can be just the guitar. I can say electric guitar, I can say musical instrument, but right, so I can flexibly adjust what is emphasized. But importantly, at this basic level, guitar abstracts away from the kind of guitar that it is. Right? So that's the experimental design. We're going to present people, this is all within subjects, one of these three cues, three cue types, pictures that either match the sound cue or not, and they either match at the level of the category or not. Okay, and we see how well people recognize these pictures following these auditory cues. So here's accuracy here is at ceiling. So we're going to use reaction time as the primary measure. Here's how long it takes people to recognize, for example, an electric guitar, a picture of an electric guitar following an acoustic guitar sound. Okay, so they mismatch at that subordinate level. And if they match, people are faster. So if they hear an electric guitar sound followed by a picture of an electric guitar, they're faster to recognize, yes, that's a guitar. What happens when they just hear the word guitar? And this is just one example of a bunch of categories we used, just using it as an example. They're faster still. So the idea here is that the label guitar can leave unspecified information that is, for the purposes of this categorization task, not relevant. It doesn't matter what kind of guitar it is. But if I'm going to use a non-linguistic cue, I can't help but convey that information. With language, I can leave it unspecified and instead activate, the theory goes, the features of the guitar that make it a guitar versus a not a guitar. And activating those features makes the person temporarily a better guitar detector, okay, a better categorizer. This effect happens very quickly. It happens at the level of visual representations. You see it, we did some EEG studies on it. You see it in the P1 component after presenting the picture. So this is not kind of a later higher order judgment making kind of effect. This seems to be changing the perceptual priors that people set after hearing the cue. Those priors are different, and as a result, people are better able to distinguish between category members and non-members. To the extent that people depend, whether consciously or not, on language when they categorize, interfering with language should interfere with categorization. We've done a few different experiments of this sort. I'll show you one, which was inspired by work done on in people with a form of aphasia. And we wanted to see if it replicated with, in this case, healthy college undergrads who have language not permanently disabled or anything like that, just mildly interfered with in a way that I'll explain in a moment. The task is a type of categorization task, an odd one out task. So people get these three types of trials. They see three pictures or words. The pictures is a nicer demonstration. And they have to pick the one that's different based on size, based on color, or based on a more global function or thematic relationship. So the idea here is that you can put jackets into suitcases. The stroller is kind of the odd one out. So that's the normatively right answer. Now, the results from this is a case study, person with good language comprehension, but poor naming, whether tested with pictures or words. This individual was selectively impaired on color and size trials compared to seemingly more difficult function and thematic trials. And the idea here was that although these trials probably require the most world knowledge, these trials require selective representation of the items so that you have to represent the color and their relationships according to color, ignoring temporarily other things. Okay, so this kind of selective representation on a particular attribute. We had participants do this task, some trials without interference or with a different form of interference, and some trials with verbal interference where they had to remember a number and were encouraged to rehearse it. They do a few of these trials and they had to tell what the number was. And what we find also for both for pictures and words is that people are selectively slowed down for color and size trials, no effect on these theme-based trials. One possibility is that it's just about having to do a secondary task. So we repeat this with a non-linguistic interference task, remembering some visuospatial patterns. And we found that this had no selective effect. So just one example in which interfering with language interferes with certain types of categorization. Lastly, more nameable categories should be easier to induce. So here's the idea. I've shown you that in this case, in the case of colors, colors that are nameable in one language are not necessarily nameable in another. Now, this has obvious consequences for communication. But is it just a language thing? Or does it matter for thought? So let's find that. So here are some colors. Here's some more colors. If you ask English speakers to name these colors in the free naming task, they could say anything at all, but about 80 to 85% of people just label these as orange, red, blue, and brown. And these English speakers have a hard time labeling. These are the modal colors. Probably see this is not a very good gray, but they have very low agreement. So this just happened to be the modal color. People name them all sorts of things. Okay. So here's what we're going to do with these. We're going to have people learn a very simple rule-based category in which on each stimulus, each trial, people see one of these colored wheels composed of 3 colors, and they have to decide whether to drag it over to category A or category B. And they get feedback letting them know if they made the correct response. Here's the structure of the categories. This is between subjects. Some people see these colors, some people see these. The logic here is identical and very simple. If it has a red slice, it's category A. If it's brown, it's category B. And then for these low nameability ones, if it's this lavenderish color, it's A. And if it's this olive type color, it's B. Even though the logic is the same, the learning is very different. It's a very replicable effect. It replicates within subjects where the same subjects see both high and low nameability categories. We controlled for all perceptual confounds that we possibly could, and made it so that the low nameable colors were, if anything, more visually discriminable. Not that it really matters here since the colors are so different from one another. It's not about perceptual discriminability. It's really, if it's easy to name, it's easy to, in this case, discover. The idea here is that we think people are more likely to reliably form a hypothesis like, is it about the red thing than they are, is it about that color thing, right? With the implication that to the extent that some colors are more nameable in some languages and other colors are more nameable in others, we should observe a different pattern in another language. If anyone wants to collaborate on this, do some cross-linguistic comparisons, we're very much game. So I focused on colors. It's not just a color thing. Here are some tangram shapes arranged to form familiar and somewhat nameable objects. So about a third of our sample names this a bird, cat, and so on. Here we can control all the perceptual features, just do a 180-degree rotation, and now form these harder to name objects, do the same exact type of category induction task, and there's that nameability effect again. So is it just a language thing, or does it matter? For at least some types of thought, it matters. Now, this is not a talk about effects of language on perception, but I couldn't resist. It's not like words change what we actually see, right? Well, they can, and they do. People who want to read a recent review of effects of language on visual perception are encouraged to look at this TICS paper. I will show you briefly one study showing a similar type of linguistic versus non-linguistic cueing effect and how it can affect color perception. So the task here is people either hear a color term like green, and or they hear just a bit of white noise. They then see a display of 4 colors, and they don't have to name the colors. They don't have to do anything linguistic. They just have to respond which one of them is different from the others. And they can take as much time as they want. Now, the actual difficulty of the task was harder than what appears here. It's more like this. Now, what's the prediction here? Prediction is that to the extent that labels induce more categorical representations. And to the extent that this applies to visual representations as well, we should see an online effect of immediately after you cue someone with a color label, it should warp their representation such that they can perform certain kinds of color discrimination better. What kind of color discrimination? So the way to think about it is this. So if we have this continuum from green to blue, after being labeled, it separates out. So the colors straddling the boundary become the most separated. The colors that are sort of the green and blue prototypes become slightly squished together. So here discrimination should, if anything, become worse. But these colors in the middle of the category, as you can see, also become slightly more separated as a result of this warping. And so this is discrimination right around the prototype. This is a discrimination in between the category, and this is discrimination between, for example, greens and blues. And what you see is, in this case, there's really not much categorical perception without labels. But when you label it, the discriminating around the prototype becomes slightly harder. Discriminating in the middle of the category and at the boundary becomes substantially easier. What if you try to convey the same information non-verbally? So let's try to cue people with the actual color that is different from the other colors, kind of a preview trial. What happens then? Well, there's no reason to think that this should induce more categorical representations, and there's no effect of this kind of cue. All right. So three questions, three sources of support for the claim that words induce more categorical mental states. Beyond these kind of specific effects, there is another reason this question keeps me up at night lately, which is that I think when we fail to acknowledge language and culture more broadly as a shaper of our even most basic cognitive processes, we risk ascribing things to, just innate human cognition, our biological heritage, that then is warranted by the data. And as a result, we fail to acknowledge, for example, the importance of certain kinds of cultural experiences, certain kinds of education, and taking for granted the abilities of some people to do certain things. Okay, and given the time, I don't think I have time to go through this case study, but I can talk about it during the question period. The case study concerns, I'll just do a little teaser, the claim that abstract geometric reasoning is part of our core knowledge. And so the claim is that when people are presented with displays like this and asked which one doesn't belong, they use their innate geometric primitives to respond and make similar choices regardless of whether their language has words like square and rectangle or parallelism or various geometric vocabulary, and importantly, regardless of whether they've had any formal education. Here is the key data slide showing the correlation on different trials of this sort, testing different geometric primitives, correlating the success of these indigenous Amazonian participants and American adults, and pointing out that there is a strong correlation. The authors neglected to kind of highlight that there's also a very large main effect between adults. The American adults compared to kids get better on this task. There's a lot of trials on which they perform perfectly. The emphasis is on the correlation. And the claim that unfortunately don't have time to fully defend is that when people do this kind of task, they do certainly rely on high-level visual primitives that are likely independent of language and education, and have become confounded with more geometric-based reasoning. But when people do this kind of task, these shapes activate associated labels. In this case, for example, rectangle, which helps you distinguish category members, this one, from these ones. And importantly, because many of these displays can be construed in multiple ways, and labels tend to collapse their dimensionality and encourage certain construals, the things that are easier for English speakers to name turn out to be easier to solve. And these kinds of things that are harder for English speakers to name are harder to solve. When you interfere with language, it affects these trials, but not these trials. If you compare performance of different groups with different levels of education and vocabulary, you find that they differ on these kinds of trials and not these kinds of trials. So to the extent that these are easier for English speakers, and they are substantially, they're easier not because of an inherent property of these stimuli, but because English speakers, and speakers, to be fair, of many languages, have words for these, and they've learned to parse this kind of display into pre-existing categories. And I'm happy to show more data if people would like. So in the first part of the talk, I tried to identify some pitfalls that have plagued this question of how language affects thought. People mean different things by language. They mean different things by thought. They mean different things by affect. And being on board with the terminology, I think, hopefully keep us from falling into quicksand. Do the words we learn as part of learning a language help structure our mind? And of course, there's much more to language than learning words. This is just the place I'm focusing on here. At least in certain respects, I would argue yes. And a larger takeaway message from this is that culture and language matter. None of us are smart enough to individually reinvent the categories we inherit from language. We can learn those categories. That's the reason they exist. If people had a hard time learning color categories, color lexicons would not be a stable property of vocabularies. But learning those categories is not the same as inventing the idea of naming colors, or of color as a nameable dimension. Once you do that, you create a kind of high-level API, right, for the human mind. So a person with a color and shape vocabulary internalized can come into our lab, and we can say, okay, if it's a square, press this button. If it's a blue square, right, press that button. Now you could train all kinds of animals to do this task, but it takes thousands and thousands of trials of training. We can use these categories, these chunks already learned from language. We can also combine them in all kinds of new ways, right? And instantly activate representations that, you know, to some extent we might want to call linguistic or non-linguistic. To me, that's not the question that matters. The important thing is that we can induce certain behaviors as a consequence of the person being a linguistic being that we couldn't do otherwise. And that, to me, that is kind of at the essence of this language affecting thought question. Thanks.
Thank you very much, Gary, for this great presentation. Now we will start the discussion session with discussant Deidre Gantner and Eden Blank. Deidre Gantner is a professor of psychology at Northwestern University, and Eden Blank is an associate professor of psychology at UCLA. I'd like to thank both discussants for joining us today.
Who would you like to have start?
Deidre, you can go ahead here.
Okay, well, great talk. I love this research, as you know, Gary. But naturally, I have some questions and thoughts. So first, let me just reiterate something I've said to you. Can you hear me? Am I loud enough? Okay. I absolutely admire the way you have sort of figured out ways to make things that, frankly, I would have thought language would not have much effect on. Show that even with concrete objects, language has all kinds of effects. This is, as Gary, you and I have discussed, I've always been interested in the profound and I think very clear effects of language on relational structure, verbs, prepositions, mathematics, that might be something to discuss with Idan, and physics, for example, technical terms, systems of relational terms that sort of form that I think without which we simply wouldn't form the conceptual systems that we form. But you have shown that even with something as conceivably as sort of mundane as a guitar, which is easily perceptually discernible, there are profound effects. There's abstraction, there's instant access, and so on. And you said some of the things you named are it enforces expertise. Yes, it allows you to compose complex concepts. Absolutely, and of course we see that in spades with relations. Like a verb like confiscate involves so many assumptions and it's sort of more local relations that can be combined into this notion of confiscate. And once you have it, you can simply throw it into a sentence. Inviting abstraction, freedom from the tyranny of the specific also. And when I teach a language and cognition class, one of the things that always comes up is, well, isn't it just about frequency? And the answer to that is frequency really matters. Frequency is what gives you accessibility. And of the many, many things that might sort of flit through our minds non-verbally, frankly, many of them flit and are gone. But when you have to use a term over and over to communicate with other people, and they have to use that term to communicate with you, and you have to align with them to get that, to continue the conversation, that becomes inaccessible, as opposed to just in there somewhere. If somebody found the right cue, it's accessible, you can pull it out. And that changes everything. So I'll stop with that for a second, but I have much more I wanted to say, but I'll let you get a word in.
So, one reason why I started with these more concrete categories and kind of kept and actually went down into lower level perception before now emerging back and doing more stuff on reasoning, like the geometric stuff I ran out of time to discuss, is that it's much easier to test more concrete categories. You have much more control. And so the thought was, I think I assumed, as a lot of people do, that the abstract knowledge, as you say, is more language dependent. And it's somewhat amusing that the very now widely used concreteness, abstractness norms that Mark Brisbert put together, 40,000 or so English words, the instructions to participants about whether to rate a word as more concrete or more abstract are it's concrete to the extent that you can point to it or enact it to convey the meaning using this sort of non-linguistic way. And it's abstract. You should rate a word as abstract if you need to use language to explain what it means.
Yeah.
Right. And so some verbs are quite concrete, like jump, you can illustrate by jumping. Right. But many words, of course, you can't, because their meaning is so bound up with their relational structure. And so in an even longer version of this talk, I had a part where I wanted to talk about what's missing, what do we really need to what kind of experiments, what kind of data. And one thing I think we really desperately need is a better way of investigating knowledge of abstract meanings. At present, most methods are linguistic. So you have people rate similarity of abstract concepts based on their names, based on words. You drag words together, right? Or which word is most different from the other. It's very hard to for understandable reasons, to get at kind of that more abstract knowledge without using language. And so the question of to what extent are people representing it non-linguistically, how is cueing it linguistically versus non-linguistically different? It's hard to do those experiments. There is work that does this, some work out of Ev's lab, for example, where you show people pictures or animations of actions where there's some inaction of thing, so you can do it, but it's very tricky. But I think we desperately need to do it. I also think the same kind of problem affects child language research, where in the lab, it's much easier to present pictures of concrete objects to a kid and ask them to label it or test their comprehension. And there is this idea that, which is to some extent true, that kids learn more concrete words before more abstract words. But kids have lots of abstract words they use early on, words like fun. And my 4-year-old for now, I don't know, a year and a half has been obsessed with transformers, and the idea of transformation that he uses pretty abstractly, it's an abstract idea. And we don't know what kids know about the words they use. So, I use the example of open. My younger kid is 1.5, and he says open. It's one of a frequent. He doesn't say many different words. This is one of them. It's a very useful word, and he seems to use it in a very particular sense, which is, I want access to this thing, right? Which is only one sense of open in English. And it would be really interesting to know whether English-speaking kids all find this initial sense easier to learn, or whether, obviously, as they become older, their meaning space approximates that of adult usage. But which senses come first? And are there certain kind of seeds of abstract relations, right, that they grab onto? Or is it really rooted in concrete situations? And I would love to know that.
There's stuff on this, and actually Melissa Bowerman, as you know, did a lot of really brilliant work on this. One of the things she observed was the kids would often use, so as you know, the thing I think we need to talk about is not just abstract concrete, we need to talk about object concepts versus relational concepts. And that cuts across in some ways, in the sense that simple little prepositions that seem perfectly concrete to most people using them, they're just spatial relations that you can look out at the world and in some sense see, are in fact cross-linguistically vastly different on, in, under, and so on. And they're not abstract in one sense, and yet in another sense they are. Well, so she looked at the way kids use those terms early on. And very often what she would see is they would use the term correctly for some time, but very conservatively, only in certain situations, which were actually correct according to the adult usage. And then at some point, it would be as though, well, I won't even say, I'll just describe the data. They would just begin to extend and say things like, open the lights, meaning turn them on, or can I have some candy behind dinner, where they took a common mapping, which is from space to time, and did their own. So the move from conservative to sort of extended as mastery, if you, in that Karmeloff-Smith sense, gets established, is one of the patterns you see in child language.
One of the, I'm not sure if it came across in the talk, but the assumption that words map onto pre-existing concepts it would seem has a hard time with addressing cross-linguistic variability.
Yes.
Right, because doesn't it seem suspicious that the posited pre-existing concepts map onto English or whatever the language of the researcher?
Just a sample of why we're the chosen people. I don't see the problem. No, really, it's so clear that cannot be the case. By the way, the Majid and her colleagues, Majid, Jordan, and Dunn, have a really nice finding on relations versus other kinds of cross-linguistically variable terms. So they looked across 12 Germanic languages at color, artifacts, body parts, and spatial relations, and basically asked people to name depictions of them, and looked at how uniformly things are named across those languages. The most variable are spatial relations. So that's quite contrary to some other theories of how it would have gone, that might have said spatial relations are part of core knowledge, and therefore they'll be the things that are most constant across language. It was the reverse.
Yeah, that's interesting. I want to let you done say something.
I'll subside.
Yeah.
I don't know. I'm enjoying this. I'm glad to do.
Yeah. Thanks so much for joining the last minute. I spent most of today doing that intro for the talk because I've wanted to do it for a while, and spurred on by our back and forth on Twitter, I wanted to engage more, and part of me feel I've been doing this for a while, and I keep saying the same thing for a while. But like more and more, I realize people come at these questions with different assumptions, and it's really useful to talk about the assumptions because they help, I think, us understand why some people take some data as obviously relevant, without questioning, like, even, how robust is the effect, but, like, is this relevant to this question? And depending on the assumptions you start with, the answer could be yes or no. And so it's really useful to discuss.
Yeah, I agree. And thank you for the shout out. I'm very glad to be here. I put the minute you put that on Twitter, I put it on my calendar. I agree with a lot of what you say. I think hopefully it's obvious at this point after our chats. And I agree that like language being distinct from other forms of thought doesn't mean that it's encapsulated, or that there's no influence and that there's no integration between different forms of thoughts or different mental structures. Right, even if you go to vision, right, color, shape, contrast, speed, orientation, we know those are kind of different modules or whatever. Of course, they have to integrate and they influence each other. There are a few things I might disagree with. Some might be more important than others. One is about this is a small thing about the language equals thought or parallels thought being a red herring. I tend to agree that if you care about empirical science, it's a red herring. But for example, a couple of months ago, or a couple of weeks ago, Chomsky gave a talk where he said basically that the goal of language is thought. It's not communication. You can't think without language. It's the medium of thought, right? So in that sense, it's still not a red herring.
I mean, he's been saying that for a long time, and I've never understood why someone who holds this view doesn't seem to care about the content of language, right? I mean, structure is important, but you would think, without the semantics, right, there's not much. And so you would think someone who believed that language is for thought would think it's important to understand where, word meanings come from. And my sense is that Chomsky and that the generative linguistics as a whole has not paid much attention to this question. There are other linguists who do, of course, but and so I've always had a hard time reconciling that view. So sure, okay, merge recursion, but what are you merging? Like, where does that content come from? What uses merge if you have nothing to merge? And I don't know if he thinks that it just comes from, I don't know, from perception, or are these innate things, or, that it's all solved. But yeah, I've been puzzled, but I take your point. Yeah.
The other thing, and I think this is where maybe you and I come from different assumptions or something, is sort of the focus on experiences rather than representations. And I think representations are sort of one of the tenets of cognitive science, right? Different data structures lend themselves to different algorithms. Different algorithms explain why some things are harder and other things are easier. Otherwise, we're sort of back to behaviorism, right? It's not just about this experience's input gives you that output. That I hope cognitive science doesn't go back to just that.
I don't think I am a closet behaviorist, but one reason why behaviorism was so popular is that it was much easier to operationalize, a reinforcement schedule or set of inputs, right, than to think about hidden representations. And so I think that remains true, right? It is easier. Of course, we still need to need to do it, but I think there is sometimes a kind of a default, right? To so for example, in that the Holmes and Wolf schematic, they immediately go to linguistic and non-linguistic representations. And that's a much more theoretically loaded term. Like, I don't know what a linguistic or a non-linguistic representation is. I'm not saying there's no distinction, but it's like a phonological, like some, neural pattern that specifically encodes the phonology of the word. Sure, right? Something that encodes, the visual, right, properties, right? Those are clear. But there is so much in between, right, where it's really not clear what kind of representation it is. And it's not clear to me how you find out. And I think the work on the language network is really important, but it seems like that's an overly kind of conservative metric of, this is active in overt language tasks, right? And so if it's not active, it's not language. That doesn't, to me, that doesn't quite follow. Whereas, right, when it comes to, did I show you a word or did I show you a picture, right? And maybe, right, when I showed you a picture, you activated the word, right? But is that what is going on, right? Well, the question of mechanism is important, and it's important to understand kind of at what level this interaction is happening. But starting with the representations, I think can introduce, in some cases, unneeded complexity.
Just weigh in for a second. I would like to agree strongly with Idan on this point. You can't even talk intelligibly about process without presupposing some kind of representation. At the same time, I agree that you ought to be humble about what you don't know, and there may not be a clear distinction between linguistic and non-linguistic. I mean, not all distinctions are equally reasonable, but I would like to make another point too, with respect to Idan. What I gather is Idan's position on mathematics. The fact that we don't see active involvement of the language areas when someone is doing mathematics doesn't mean that language wasn't formative and necessary in learning mathematics, learning, for example, the cardinal numbers, learning, the beautiful structure of math. 5 is going to be half of 10, which is half of 20, and so on. all of that, as far as I can see, is strongly influenced by language. And there's several lines of evidence. There's the Piraha and the Munduruku, who have either no language or very minimal number language, and they have also very minimal sort of mathematical skills. There's Ian Lyons, who has, I think, done a beautiful job of showing that as kids learn, the big predictor of how good kids are at learning math in various ways, and even including their ability to do the kind of tasks that are often cited as approximate number, the ANL tasks, is best predicted by their ability to sequence numbers, actually cardinal numbers, symbolic numbers. And finally, Jessica Sullivan, who's done work with David Varner, has a nice study showing that people map the structure of the cardinal numbers that they know onto quantities, and that this is the way that, in some sense, if they learn mathematics and learn the structure of actual quantities. So it may be that that once those representations are there, we don't need to access language to use them. I think that's quite plausible. But at the same time, no language, possibly no math.
I mean, I would agree. I'm interested in what Gary has to say. I would agree. I think the question of language scaffolding a lot of thought during development is separate. I mean, related, but separate from what happens once things are there. To the extent that it even makes sense to separate development from online processing, which is a weird separation. But yeah. I agree, and I find some lines of evidence very convincing, not just in math, theory of mind, for example. But so one piece of evidence from Piraha actually that I think is interesting and might go in the opposite direction is that if you have them match, 10 spools of thread to 10 balloons, they can do it. So they understand that +1 or -1 gives you a different number. They understand that perfectly. What they can't do is keep that quantity in mind, right? Because they don't have the count list. So some things you can get without it. Other things, yeah, I would agree, without the math, without the language, you wouldn't get in there. But anyway, Gary.
Well, so I certainly agree that, and often it's labeled as offline versus online effects of language, that these are logically and often empirically separable, and it's important. And so, for example, to what extent should we expect that in aphasia we have an impairment to some cognitive task if language is involved? Well, if it's primarily an online effect, yes. If it's about language having scaffolded the system to be there, well, having aphasia doesn't negate a lifetime of language experience, and so you might not see any effect. But I think this highlights the difficulty of talking about linguistic versus non-linguistic representation. So in the scaffolding story, I mean, the counting routine is a linguistic experience. Count words are, phonological, or in the case of sign language, visual phenomena. But at what point is this ostensibly linguistic representation at what point does it become non-linguistic? It's not talking about representations that I find sometimes problematic. It's classifying them as being, a linguistic representation. In the case of modalities, it's also, I think, often problematic, but somewhat more straightforward, since we, for example, know a lot more about the visual system. But even there, there are all of these cross-modal influences. And so you find, for example, seemingly visual responses to sounds when people are doing basically object identification from sounds. Is that now no longer a visual, no longer an auditory representation? I think it just becomes messy if we want to slap a label on these are all neural patterns, right? But the labels are coming from us, so from scientists. So, yeah.
Yeah, I agree. And using language in science is probably one reason why we end up with these very problematic questions that we can't agree on. I don't know if we, but we as a community.
Yeah, yeah.
I mean, not all classifications make sense. And I agree with you that linguistic, non-linguistic may not be one of the more informative ones.
Yeah, I don't know. I'm on the side that thinks it's like if we want to carve the mind at its joints, then language might be like trying to ask what is language and what is not language. You know, we at the end might be fuzzy, but I think there's been progress in like separating some things that are clearly not and some things that clearly are, and we might be getting to the place where we'll hit a wall and we'll say, okay, at this point it's no longer useful, but I don't know. I wanted to ask you, Gary, about using the word categories and language being categorical. And so, and sometimes, like at some points you say language is categorical, at some points you said language induces more categorical mental states. And I think that's an important difference. Like, do we mean that when we use a word, we have less uncertainty about specific things, or less uncertainty overall, right? Because our category is binary. How do we fit all the probabilistic inferences into that?
Great. Yeah. So the first observation is that words are discrete, right? So we don't blend between words. We can express uncertainty. We can use language to say, that's kind of green, right? So there are ways of expressing those sorts of shades of meaning, but we're, for the most part, stuck with using categorical labels as language. And there's a good reason for that, because they combine very well, right? Whereas the
label is categorical, right?
Yes.
Like the word form is distinct from other word forms.
Yes.
What constitutes green, right? Where are the boundaries of green? What is a sandwich? What is a bachelor? Like those things Absolutely. Are not.
They're not categorical. So how do we reconcile that? And So let me see if I can present it succinctly. So everything is graded, okay? I was brought up in the connectionist school of thought. So, for me, everything is graded and distributed, including things like formal categories. So when Lila Gleitman noted that categories like odd and even and triangle show typicality effects, brilliant paper, right? The conclusion was, therefore, typicality is nonsense, because look at this ridiculous result you get. The other alternative is that, no, that's just how it is. People think 400 is a better even number, right, than 398. They judge it more quickly as even. They make fewer mistakes. They think equilateral triangles are better and are more likely to have 180 degrees. And so what's interesting is that despite this, people often transcend it and reach the right answer and make the correct inferences. But the easy thing for us is to treat things as being graded. And arguably language, and in this case, these more formal systems of mathematics, of geometry, help us get over that, right? And so we learn, no, all triangles are 180 degrees. Doesn't matter what it looks like, that's just a defining feature of a triangle. And so, how is it that people compute with graded notions of integers? Badly, right? People are terrible at mental arithmetic, right? Like if they had crisp, right, digital representations of numbers, maybe they would compute better, right? But and so people invent various devices and heuristics to get around this. What is what to us is, I think, more natural to represent things in this graded way. So, okay, so a penguin, right, is a less typical bird than a sparrow. And you can see that in naming, you can see that in patterns of inference. And so what happens? So what I think happens is, under the influence of language, right? So what is the effect of, say, bird, the word bird, on your representation of a specific bird? What I think happens is that the word highlights, you have a distributed representation, and you are accentuating the parts of that representation. I'm going to say features, but it's not about like, has wings as a feature. It's just part of this distributed manifold. It highlights things that are diagnostic of birds, that distinguish birds from non-birds, and abstracts over things that are irrelevant, that are true of the specific bird, but are not predictive of birds. So as a result, the representation is more categorical. It is more similar to that of other birds and more dissimilar from non-birds. So that's the idea.
I would agree.
I saw
with that.
Dejri frowning when I say people compute badly.
I agree with that too. I just want to note that you don't have to be a connectionist. Eleanor Marsh made those points a long time ago and had tons of inventive data. But of course, it's also true that when you say bird, you don't just get the diagnostic features, you also get the typical features. So you'll be faster to recognize a sparrow than a turkey, for example, after hearing them. So you sort of get the package.
Well, so I think the two often go hand in hand, that the things that are typical in part because they're frequent, but it's not just that. It's that they're frequent and they're diagnostic, right?
And alignable across the species,
Yeah. And so it's a little bit mysterious, actually, why certain triangles are deemed across a bunch of tasks more typical, right? Well, it's a little...
If you Google triangle, you get nothing but equilateral triangles, and you have a really hard time accepting that isosceles triangles are triangles. So
it shapes the input, but also why do people draw those? Why are they the illustrations in kids' books? There's a chicken and egg question, right? It's not true that there are more equilateral triangles in nature, right? So it's not just about your ambient input.
Relational things, which in some sense, geometric figures are somewhere between relationally defined and sort of also having a prototypical objecty shape kind of thing. But it often turns out that the ideal is more, it behaves more like the prototype than the average. This is work on phenomenal relational concepts that Art Markman and his colleagues have been doing. But so, for example, the perfect diet food, I think Larry Barcelo did some of this too, has 0 calories, even though that's not a typical diet food. That is the sort of, in some sense, the ideal, and it's the one people often think of. Anyway, so I want to mention one other thing, and then we'll turn it over to the chat. There's a different distinction you can make than the concrete abstract distinction that you described the criterion really nicely. If you have to use a word, it's abstract. We have asked people to distinguish between its entities and relations using where the stimuli are nouns. So barrier would be a relational noun, and giraffe would be an entity. And the criterion is, if I ask you to go get one, can you identify it just on its own? Or do you have to see it in relation to other things? So for example, a thief has to be seen taking the goods of a victim. You can't just identify them by the way they look. Whereas a giraffe or a rabbit or a tulip, those are the easy ones, of course, can be identified intrinsically. So anyway, I think that's a distinction that's worth thinking about. It's highly correlated with abstract concrete. Where we get non-abstract, we get abstract entities and concrete relations. It's quite hard.
So I have a question. So that there is, the work about this transition, right? About kind of the meaning of island in terms of, the relational, right, surrounded by water versus a kind of more perceptual, island with palm trees. And so to what extent do you think that's it's just inherently harder for kids to represent these relations, or is it that, there are certain things that are frequent in exposure, and it's not that a child has of a particular age has trouble understanding, that this is what makes it an island, but it's just sort of competing with salient perceptual information that is, after all, often diagnostic. That's why it's frequent.
Well, salient perceptual information is always important, but let me take an easier case. It's take forever to learn prepositions, even though they're way more frequent than the concrete nouns that they're sopping up at an amazing rate, right? And even when they get their first preposition, often it'll be up, but they only, typically in English, it's not uncommon, I don't know if this happened with your kid, that they only use it meaning pick me up. And it might be used that way for the first month, and then at some point they also use it for putting an object up. They're hard, and they're hearing them all the time, and in some sense, they're perfectly perceptual, but they're too many. Here, my analysis, for what it's worth, is some things are easy to individuate, and of course, the ideal thing is an animate being with a good structure that has common fate in the Gestalt sense and moves together. That's a thing. When one part of it moves, the rest of it moves. It has intelligible structure and so on. And there's studies that Susan Carey has done and I've done and so on that have looked at, and Musumi and I have looked at how easy it is for kids to take a thing as an object versus the substance, and the degree to which it has complex intelligible structure matters. I think that's a big plus for many concrete objects that kids encounter. And relations just don't have that. And we know that they don't, because different languages carve up the world differently when it comes to relations.
Yeah.
There's a question in the chat that I can read that I think is somewhat related to the saliency of perceptual versus linguistic things. So someone is asking whether you think auditory interference could affect your visual working memory. So if you hear the word red while you're seeing a blue dot, would that alter the storage of the blue dot in your visual working memory, or do you think the labeling wouldn't be strong enough to sort of affect perception categorization?
Yeah, I think there's actually data on this, and I can't think of the paper. I remember seeing this at Vision Sciences. I'll try to dig up the reference. I'll tweet it out. If my memory serves, that the answer is yes. So we did a study with Emily Ward on using auditory cues in I think what is lower level than working memory, just a simple detection task where there's a continuous flash suppression that makes an object invisible. This is operating at a fairly low level as far as the neuroimaging tells us, the general procedure, and labeling the object beforehand, so hearing the word pumpkin, made it easier to see the pumpkin. So it unsuppressed an otherwise invisible pumpkin, but it didn't cause you to hallucinate a pumpkin that wasn't actually there. So it's not just shifting your criterion. And the idea is that it's about activating shape information. So to the extent you have a weak bottom-up stimulus, and now you have a top-down prior, to the extent that they are congruent, it'll help if you mislabel it. If you hear zebra, but it's a pumpkin, it makes it slightly harder to detect compared to the valid label. And you can morph between a circle and a square and find that, it's kind of a continuously varying effect, where for like a square circle, either label can help you a little bit, and square suppress a circle and circle suppress a square. And so I would imagine that the same mechanisms are at work in memory and would provide similar kind of facilitation or interference. Yeah.
All right. I have maybe a generalization of this question in a sense, and this is mostly calls for speculation, but you've thought about these things way more than I have. So I'm interested in your speculation.
I like to
and
speculate.
That is, I'm assuming words don't always have an effect in all of the cases, right? And usually the papers we see are cases where that works.
Yeah.
And so do you have any ideas on what determines when we can see, or under what circumstances, or in what domains we can see effects of language on other like thought, perception, and so on?
Yeah, so I think, okay, so I have two kinds of answers. One is about the type of task, and then the second is about the type of linguistic phenomenon. So as far as the type of task, I think tasks that focus on categorization are more likely to find these kinds of effects because of this discrepancy that I mentioned. In working in the space, I've been surprised a lot. So for example, intuitively, it seems that there is a trade-off between categorization and memory for specifics. Like if you're categorizing something as a bird, you're not also representing it as a specific bird. And we do have work showing that labeling things, like labeling chairs as chairs, made it harder to remember which specific chairs you saw. On the other hand, when you look at individual differences, you don't see a trade-off. So people who are faster at categorizing are also tend to be better at remembering details. And other manipulations that I've tried that kind of enhance categorization don't really like decrease memory. Like they don't trade off in the way that you might think. And it's been, and in other cases where I've had people label things, you know, it overtly label things, it improved memory in unexpected ways. And some of this has been presented as posters and stuff, but it's hard to kind of publish because I don't know what to make of it. So focusing on categorization seems to be, you know, where a lot of these effects hide. And then the other thing is, okay, so Worf mostly was concerned with grammatical differences. And people who've looked for grammatical differences sometimes find effects, but they're kind of hit or miss, right? It's kind of more of a mess. So people who, you know, try to find an effect of, say, you know, grammatical gender or aspect, you know, find positive effects, but then others show things, you know, experiment after experiment that like, look, this should work, but look, it's a null finding. And it's hard to argue from null findings, but, you know, they're telling us something, right? And Dedre, I think you were there. It was like a symposium or something at Psychonomics, and Barbara Malt was there also. And I don't know if it was you or if it was Barbara who pointed out that like, it does seem like the people who've been looking more at labels and vocabularies tend to find effects, and people who look more at the grammar tend, you know, not to, or that it's much more mixed. And that's interesting. Yeah, you know, where I think the intuition is that, look, grammar is so pervasive and it becomes so, you know, proceduralized that like you should be more likely to find an effect. But on the other hand, like once something is that proceduralized, you know, to what extent is it like psychologically real? I don't know. I mean, I think there are, you know, so my first language is Russian. And I learned English when I was a kid, but there are kind of things that have carried over, right? So some, like I probably use some prepositions in ways that are not like canonical in English, but I often catch myself like using, you know, foot and leg like in the wrong way, right? So Russian doesn't distinguish between them. And, you know, even after most of my life, right, where I have the English category, it seems like there's extra work to make that distinction, right? You know, and grammar, right, of course, varies. Things that are optional in one language are obligatory in the other, but it's much more of a coherent system compared to words, right, which you kind of choose anew, and I don't know if I'm making sense, like voluntarily, right, in a way that, you know, so just speculating that some of these grammatical differences that have been so much of the early focus, yeah, they might not matter as much.
Well, it's okay. Let's be specific for a second on this. So two that have been talked about are in theory of mind, the Gilles de Villiers idea that learning to do certain kinds of clauses where belief clauses, he believes that X, so you have a whole proposition, that's critical. And it seems to me there's a fair amount of evidence for that. But let's put that there. And then, so I would say that one is, I mean, yes, there's been a lot of skeptics, but it seems to me I see quite a bit of evidence. Then on the other side, there's this notion of whether when you describe an event, you have to say whether you witnessed it or somebody else told you about it. That always seemed like a really powerful one. I thought that would have a big effect. And as far as I can see, that's really gone back and forth. I don't know what you would think about that, Gary, in terms of how solid. So do you have comments on those two?
Yeah.
Claims?
So I find the theory of mind stuff quite compelling, but I don't find any of the offered mechanisms like a bulletproof. You know, they all seem to have certain problems. So speaking for myself, my hunch is that, you know, there is so much about mental states, right, that is unobservable. Like we infer certain things from expressions and from people's actions, right? But so much of what we learn about what people are thinking is from them telling us. And so if, for example, as in the work with home signers, right, like if you're missing that information, you can still observe, right, and make all of the same inferences based on the information you have about what people, you know, what underlies people's behavior, right? What is the generative function, right, that gave rise to people's behavior? But if you lack access to what people are actually like telling you about, you know, what they thought when they did X or what someone else thought when they did that, right? That's a huge source of information. And so the theory of mind deficits in home signers, I would expect like something like that is a, you know, more straightforward, if less specific account. The developmental trajectory, I haven't followed that literature as well, but I mean, I guess want to know is, you know, do we need to posit the critical importance of a particular like syntactic construction, or is it really just about soaking up all of these distributional information about what people say about what they're thinking and kind of correlating it with their actions, right? And that is the raw material from which people kind of construct, right, their theory of mind.
Yeah, I don't think the claim is you couldn't get it without language, unlike, say, mathematics. What the claim is, you get it earlier. So, you know,
yeah,
deaf kids who have sign, who learn ASL get theory of mind. There's a very nice study by Tomasello and some colleagues. I'm embarrassed, I can't remember the colleagues' names, but I'm pretty sure he did not start off expecting to get this positive evidence, and he did. That hearing the sort of the belief clauses, and even, I mean, the cool thing is even getting the syntax of, he says that she went down the street. So even the syntax of an embedded, you know, sentence is helpful. And so is, you know, people just showing you, oh, I bet this is going to be, you know, candy. Oh no, it's not candy, and so on. That also helps, but syntax helps, you know, will add to that. So
yeah.
I mean, yeah, I agree. I mean, there's the study by Tager Falsberg, right, where you teach kids intentional complements, but without any mental state verbs, and they suddenly are better at passing false belief tasks. And
that's interesting.
And the home signs, I think one thing that's fascinating is that, you know, what the study about the theory of mind, at least the one that I know, is they are very bad at theory of mind, at false beliefs, even after 20 years of exposure to the social world. which is incredible, right? And then when they start the cohort 1, when they start interacting with cohort 2, they get better, but they like even after 2 years of getting better, they're not matched. They're just not as worse as they used to, as like bad as they used to be.
But to be to give Gary the some leeway on this one, they're missing a lot of information when they don't have. It's not just sentential complements, but all kinds of information.
I agree. I think that's a way more likely explanation than Gary's explanation.
Yeah.
At least the more parsimonious and I don't know.
For the really, really late development. But
Dedra, with regard to evidentiality, I would love to see a tighter integration of the literature with all the literature on source memory. Right? Because I mean that's really what it is, and so I don't have a strong perspective on this. Like, personally, I would love to see strong evidence of evidentiality effects on memory, and where like a method that I find very elegant, right, is where you show not just that people are more likely to, attend to it and code it, right? But that, so it's not just like a preference to attend, because, hey, you might need to talk about it, but that if you, try to get them to ignore it, it's hard. And if you try to get someone who is not used to the evidential system to learn it, right, there is resistance to it, right? And that would be quite compelling. But I could imagine that this is one of those things where, just pivot a little bit, where in a language without evidential markings, the mean might be different, but you also have just a lot of variability, because some people, for whatever reason, are good at attending to, how they learned something, they have good source memory, and other people are not. And so that difference is masked. It just doesn't matter until you test it. But then if a language forces everyone to attend to that, right now, everyone has to get on board. We've done a bit of work on inner speech, and this is one of these domains where, and I would love to see how it plays, like interacts with the language network, right, where people's subjective experiences really vary, with some people experiencing a constant linguistic kind of narrative, right? And other people saying, what are you talking about? Like, I don't hear a voice. That sounds crazy, right? Most people experience inner speech. It's a right skewed distribution, but just like with visual imagery, and the two are positively correlated. Some people, if you ask them, well, how do you experience your process of thought? They say like, well, I think in ideas, right? And ironically, right, because we don't really have the language for talking about it, it's hard to know what precisely do they mean. And it's hard to know, in what ways does it matter and not. But it's interesting that there is this subjective difference. It has high retest reliability. Like it's a thing. We just don't know what, if any, the consequences are of this. And I anticipate that some of the messiness in getting effects, some effects, some people not other, like maybe it has something to do with that, right? Like where there are different solutions, and maybe some people are more relying on language, both in the moment and kind of offline, than others, right? And you average it together and you get kind of a mess. So. We'll probably wrap up. Are there questions?
We don't have any more questions in the chat. So do you have any other questions? If not, I'd like to thank you, Gary, very much
Yeah.
for the collaboration with the series Abralinha ao Vivo. I'd also like to thank both discussants for accepting our invitation. And Gary, would you like to say something before we end the transmission?
No, this is fun. Thank you for organizing, and thank you, Dedri. Yeah, it was great to have you on.
Thank you very much, Gary, once again, and thanks everyone. Until next time. Bye.
Thanks.
Great talking, Gary. And you done.
Yeah,
Yeah.
thank you for having me, and great talk.
Really fun.
Yeah.